Hey guys, we're back with the notes for 7.3. Today we're going to be moving back and forth between rational exponents, which just means fractions as exponents, and then radicals, which is like the square root symbol, using maybe to the square root, to the cube root, to the fourth root, that kind of stuff. Okay? All right, so the first thing I want to make sure you do is pause the screen right here and copy everything that you see, and then we'll talk about what's in the boxes. Perfect. Okay, so the first thing you need to know is when you're moving back and forth between rational exponents and radicals, that the exponent, like whatever your power is, that's going to make your numerator of the fraction. Whatever your index is, or like the third root, fourth root, fifth root, whatever type of root you have, that's your denominator. So a square root would have a denominator of 2. Okay, so let's go through the first couple of these, and I want to just kind of use some small highlighters to talk about how we convert from one radical form into rational exponents. Okay, so right here, if I have the cube root of x raised to the second power, I can take the 2 and the 3 and convert them into one fraction. So the 2 is going to be my numerator, and the index, which is my radical, is going to be my denominator. All I'm doing is rewriting it. I'm not simplifying or solving it. I'm just writing it in a different way. So let's do the same thing on B. So on this one, my exponent or my power was a 2. That's going to be my numerator. My index, which is my fourth root, is going to be my denominator. Now, in this case, you kind of get lucky. You can simplify because 2 over 4 would be 1/2. On this one, it's rewritten a little bit differently with some parentheses, but it's exactly the same. If I say the 7th root raised to the third power, that's the same as saying I'm using my 7 as a denominator and my 3 as a numerator. I'm just writing it as a fractional exponent, okay? All right, if you need any time to copy what you see, please do that now. Let's move to the bottom. All right, so for this whole set of problems, we are going to be writing them back and forth. So anytime you have an exponent of 1 over something, that means you don't write an exponent. Your power is just to the first. Anytime you have a number on top, though, you have two options. You can either put it under the radical or outside of parentheses. So whenever we see that, I'm going to do it both ways, okay? All right, let's talk about this first one. I know that I need a cube root because these have the denominators. Let me do that in blue first. Okay, so I know that this one needs to be a cube root. And then I would not say 7 to the first power. I would just say 7. That's all you're doing. If it says write in radical form, that's what I want. Okay. All right, this one, I have a fourth root because the denominator was 4, but I have two different options for what to do with the 3. The 5 is definitely under the square root, but I can either put the 3 with him or I can put the 3 on the outside of parentheses. Both of these mean the exact same thing. Okay, it would not matter which one you gave me. All right, same thing on this one. I know that I have the 9th root, and I know that I have a -2. If I put it under the radical with the 4, then I have to keep that 2 in parentheses. Very important. However, if I leave the -2 alone and put the 4 on the outside, then I do not need parentheses. Both of these are correct answers, but this one must have parentheses if the 4 is inside. Okay. All right, looking at option D, same thing again. If I'm taking a cube root, I have two different options. I can either put the -2 with the second power inside, or I can put the second power on the outside. Either way is exactly the same answer. We have one more of those. We have an 8th root. I can either put the -11 inside with the 7th power, but it has to be in parentheses because it's negative, or I can leave the -11 alone and put the 7 in the outside of parentheses. Okay? If you need to pause that for just a second, copy it down, you may do so. We're going to go the opposite direction now, okay? So now, whatever our index is, that's going to make our denominator of the fraction. If we have an exponent power up here, that is going to be our numerator, okay? All right, let's start with A. I do not have a power on that 4. It's just a 4 by itself, so I would say 4 to the 1 over 6. 4 is always raised to the 1 if there is no exponent written. okay? You don't have multiple options on these. You will have to write it as one fraction, okay? All right, let's look at B. So B, I take my 33, that's what's inside my radical. My 2 is the numerator, my 3 is the denominator. So one more time, whatever's on the outside or whatever the power is, numerator, whatever the index is, that's your denominator. Going on to the next one, that negative needs to stay on the outside. There are no parentheses going on here. So it's like saying 5 and then 2 over 3, just like we had a second ago, and I can throw that negative straight onto the outside. I do not need parentheses here, okay? Now, on this one, I do need parentheses because I need to show that that negative 16 is what is getting raised to the 1/4 power. Okay, I cannot say this. If I wrote it that way, it would mean this statement, and that is not the same thing that I have, okay? Which means that if that 16 is inside, I need it to stay inside before it has the exponent on it, okay? Just to be clear, because this is an even number, you actually cannot have this. This does not exist, okay? It's kind of like square rooting a negative. You can't quarter root a negative either, okay? All right, last one, we're gonna take that 39, 4 is our numerator, 7 is our denominator. If you need to pause, write anything down on this page, you may do so now. We're going to the next page. All right, so on the next page, now we're a little more focused about simplifying things and actually finding out what that root is. So let's go over a couple things. First of all, in being even or odd matters. Just like we talked about, like you can't square root a negative. If it came out to be something negative, let me just write that real quick, then I would not have an nth root, just like you would not have a real solution. But if n was odd, my index, if that's odd, then it is possible to have that, okay? It is possible to come out with an answer. If your if your a is a 0, let's say if you square root 0, your answer is always going to be a 0. It doesn't matter what index you use or what power you raise it to, it's always going to stay 0, okay? The last thing you need to know is if n is even and you take a root of it, you have to use plus or minus. So if I was to write a quick note, that would be anything like taking a square root of a number, taking a 4th root of a number, or taking a 6th root of a number. Doesn't matter what's in the radical. Ooh. All that matters is if your index, like that little number before your radical, if he is an even number, you have to use plus or minus, okay? If he's not, then whatever you have just gets to match, okay? And I'll show you 2 examples of that in just a second, okay? So let's talk about A. If I tell you the index, the n, is 6, that means I'm doing a 6th root of 64. Since n is even, I would need to know that my answer is a plus or minus. I have 2 different options. What this is saying is what number multiplied by itself 6 different times would give you 64. Well, if I do 2 times 2, that's 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So the 6th root of 64 is 2, but I put the plus or minus with it, okay? Same idea on B. If I say the nth root of negative 32, right now, n is odd, which means that since this guy is negative, my answer is going to be negative. The question is saying what number multiplied by itself 5 times would give you a 32, okay? And then we'll just put a negative on it. So 2 times 2 again was 4, times 2 is 8, times 2 is 16, times 2 is 32. There are 5 of these here, so my answer is 2, and then because it was negative, we make it match, okay? All right, for the ones right below it, you can type these into a calculator. Let me kind of make work really, really small. Let's say you were, do not write this down, just listen and watch. If you were going to write something like 4 to the 2/5 power, you could type it in a calculator like 4 raised to the, make your fraction, where it does like the little box like this, and then type in 2 over 5. Okay, you can also do raised to the 2 divided by 5. If you put it in parentheses, it will make that a fraction for you. All of those are the exact same thing. You could even do the button that has the nth root. If you do that, you could write it out. Remember, it was 4 to the 2/5. You could write it out as the 5th root of 4 squared, and you could type it in like that. It's all the same thing. On these first ones, we're going to type them in a calculator though, and we're going to get the answers from those, okay? So if I type in A, B, C, and D, you should get those answers. I'm not going to show you a calculator right now, but that's how you would type them in. Go ahead and copy those down for a second, and then we'll focus on the bottom. Perfect. All right, so last set is down here. We need to simplify these with no calculator, okay? Here is my suggestion to you. Somewhere on another sheet of paper, whether you do it right now or at another day, I would highly encourage you write down all the different levels of powers for the number 2, probably up to the 5th power for the number 3, probably 4th power on 4, maybe 5th power on 4, but you write out a couple of these, okay? I'm going to go through these, and as we talk about them, I'm going to add them to our list, okay? All right, let's start with this first one. By using A, I want to rewrite this in a way that would help me make sense. For me, I'm do better in radicals. So if I was to rewrite this, I know that I'm going to have a square root of 16. And I don't want to make 16 larger. I want to square root it first and then take it to the 3rd power. Because I know what the square root of 16 is, right? Square root of 16 is 4. So 4 to the 3rd power would be like saying 4 times 4 is 16, times 4 gives me 64. So my answer would be 64. Okay? Let's do the same kind of thing on this one. So for B, we've already talked about what the 5th root of 32 is. Okay, I know that's 2, which means that I could take the 5th root first and then raise it to the 3rd power, and it would look like this. 2 to the 3rd power is 2 times 2 times 2. That gives me 8. So if it's easier, or if you can actually take the root of that number, go ahead and do that before you raise it to the power. Some of these, it's going to be easier to apply the power first before doing so, and we'll talk about that in a second. Okay, moving to this one. I know that it's easier to take the cube root of 1,000 because I have 3 zeros here. Okay, just like the square root of 100 is 10, the cube root of 1,000 is 10. So I'm going to do that first. I'm going to cube root to get 10, then square it to make a 100. Let's do one more of these. This one has a negative. And if you remember talking about the properties of exponents, if they're negative, we've got to change some levels. So here's how I would solve this. I would do the same thing again with the cube root of 1,000, and I would keep it raised to the -2. When I get the 10, then I would edit his level. So I'm going to move to the side a little bit. From here, that's where I would change it to a different level. I would move it down to make it 10 regular squared, and then apply my exponent, which is 1 over 100. Remember, you're doing this without a calculator, so it's important to understand your steps. If you knew to go straight from here to here, I'm fine with that. If you wanted to say 100 on a different level and then move it, that's fine too. All right, so I told you as we go, we're going to write out some of these powers, making sure that we hit a couple that we know. All right, so we learned that 4 to the 2nd power was 16. 4 to the 3rd power was 64. We learned that 2 to the 5th power was 32. Up at the top, we did 2 to the 6th power was 64. And we had 2 to the 3rd power was 8. Okay? I think you would know 2 squared without us having to write that down. All right, another one that we just learned was 10 to the 3rd power gives us 1,000. I'm going to go ahead and put 10 to the 4th power. That would just mean you have 4 zeros. Okay. These would be things that at some point I would put them on a note card and start memorizing those and looking over them, because you will be doing a significant amount of this unit without a calculator, just so you know. All right. All right, I'm going to switch colors as we go to the next row. All right, so on this one, I'm rewriting this as the square root of 9 because I know what that is. And then I will take the negative first power. Okay, square root of 9 gives me 3. The negative 1 means I change his level, so 1 over 3. This is my answer. Second problem, a little bit tricky. This gives me the 4th root of 256. Now, if you weren't sure, you could kind of play around with this one a little bit. We've already talked about 2's, okay? I know that 2 to the 4th power was not going to give me that big of a number, so I could try the next number. I know it's even, so I'm not going to use 3's, so I would probably try 4's next. I would say 4 times 4 is 16, times 4 gives me 64, and I could check that. Times 4 gives me, oh yeah, 256. So right here, since I can take the 4th root of it, that helps me to do that before making the number larger. Before, I wouldn't want to do 256 to the 3rd power. That's crazy. That's a giant number. So we would say that gives me 4 to the 3rd power. And then we've already talked about 4 to the 3rd power gives you 64. Now, this is the first time that we've had an even index. Remember that when you have an even index, you have to make sure you keep plus or minus on the outside of these. And I lied, we actually had it on this one too. So I do need a plus or minus on E and on F. Okay. All right, let's move to G. So G, again with 343, that's not a number you may recognize. But I definitely know that making it smaller before making it bigger would make my life easier. So I'm going to do the cube root of 343, then square it. Okay, it's smaller than like 1,000 that we've looked at, but it's bigger than 256. So I'm thinking since it's odd, I'm not going to try my even numbers. I'm not going to try 2 and 4. I'm going to start at the bottom and maybe try 3. Okay, so 3 times 3 times 3, that would be 9, and then 27. Nope. If it was using 5s, it would have to end in a 5 or a 0. So I know 5 doesn't work. Then I would try 7. 7 times 7 is 49. Times 7 is, 343. Some of these you are going to have to check and test before understanding and memorizing them, okay? All right, so I get that this one's going to be 7 before we square it, and then we get 49. Last one in this row. First thing we're going to do is do our square root of that negative 16. We're going to make it smaller because I can square root 16. Then raise it to the 3rd power. But right now, I notice that you can't square root a negative number. So we're going to say right away, it doesn't matter, this one does not exist. I could not square root a negative number. Okay. All right, I'm going to add a couple of these to our list. We did 3 squared. I don't think we need to write that one down. But we did do 4 to the 4th power is 256. I think that's an important one for you to know. Another one that we did was 7 squared and 7 to the 3rd power. So 7 squared was 49. 7 to the 3rd power is 343. That's definitely a number you're going to want to have memorized. Okay. All right, we have a couple more. I'm going to change to, let's go green. All right, on this one, keeping the negative on the outside because that's where it's at. We're going to do the 4th root of 625. And then we can raise it to the 3rd power. Okay, it ends in a 5, and we've already talked about a couple of these, right? We know it's not 2 to the 4th power. We know it's not 4 to the 4th power. We know it's not, I guess we haven't done 3 to the 4th power. We could check that. So 3 times 3 is 9. 3 times 3 is 9 again. And if I put those together, that'd be 81. So it's not going to be that. It's going to need to be much bigger. You might already recognize that since it ends in a 5, it was being multiplied by a 5. So 625 to the 4th root is going to give us 5. Okay? 5 to the third power, remember that's 5 times 5 is 25, times 5 more gives us 125. So our final answer will be a negative 125. Want to do a quick reminder? This is an even index, which means that even though there's a negative on the outside, it's still going to be plus or minus. Even if I negated that, it would still kind of look like a minus or plus. It's not changing, okay? Still plus or minus 125. All right, moving to J. J means that I have a fourth root of 81. We actually just wrote that one out, right? Raised to the negative 1. We said that that was 3, right? Because 3 times 3 is 9. 2 more 3s is another 9. And 9 and 9 together is 81. If I have a negative 1 as the exponent, remember that that means I need to move it to the bottom. And because it is an even index, we have to use the plus or minus. All right, looking at K. Looking at K means we're going backwards. All right, so I'm going to rewrite this back because I want to take the fifth root before I do the 32 to the third power. So I'm going to rewrite it as 1 over fifth root of 32. I'm going to make that a little bit smaller font, sorry. Fifth root of 32 and then to the third power. So we've already done fifth root of 32 is a 2. So 1 over 2 to the third power. 2 to the third power, remember, is 8. So this is my final answer. And we have one more. And this is one of the ones where I was telling you sometimes it is easier to apply the exponent. I wouldn't want to try, don't write this down, but I wouldn't want to try to square root 2 and then square it. Okay? Instead, I would want to go ahead and use the 2 squared first to make it a 4, and then I can square root 4. I would go ahead and make that a 2. Now, even though there's no number here, it's still kind of like a 2, right? There's a 2 on the outside. Since that's even, we do need the plus or minus. Okay. All right, let's write out a couple new ones that we added to our list. So we added 5 to the fourth power was 625. 5 to the third power is 125. And 3, we haven't done 3s yet. 3 to the third power is 27. 3 to the fourth power is 81. Okay, I think that's all the new ones we added in that row. We have 2 more. All right, let's go in purple. Last 2 problems. All right, this one, I think it would make more sense to rewrite it as one full piece. So I'm going to show you this 2 different ways. 1, I can't cube root 2, so it does make sense to do the exponent first. 2 to the third power is 8. And then the cube root of 8 takes me to 2. Another way you could do this is you could rewrite it as 2, putting your index as the denominator. Ooh, those are really big highlights. Hold on. Putting your 3 as the denominator and this 3 as your numerator. Think about it this way. If you have 3 over 3, isn't that just to the first power? Which gives us 2 as a whole. So if those 2 numbers are the same, it's kind of like they cancel each other out. All right. Using that same information, we could do the same thing on n. So you could say 7 to the fifth power is, oh my goodness, a giant number. Or we could just understand that 7 to the 5 over 5 makes it a 1. And my answer, therefore, is 7. Okay. All right, if you need any time right now to pause, copy all of that down. I know that's a long video, but we are all set with back and forths between rational exponents and radicals.